Hey, what's up, guys? My name's Nicole. I am with Global Inheritance, and I am really excited to be bringing you some live entertainment tonight with our movie club discussion. So tonight we're going to be talking about Chasing Coral. We have Zachary Rego, a camera technician actually turned cast member from the documentary. We're really excited to have him joining in. Before I go ahead and add him into the feed, I'm just going to give you guys a quick explanation of Movie Club and what we're doing here. So with Movie Club, each week we send out weekly recommendations for our favorite cause-based films. Just with the increase in screen time that we're all facing, we just kind of wanted to offer an opportunity to make that time more meaningful and exercise our brains, collaborate a bit on what we can do to address these super important global issues. So without further ado,
Figured it out.
thanks for being in here today.
No worries. Thank you guys
We're,
for putting it together.
yeah, we're really excited to have you. I've seen Chasing Coral probably like 3 times by now. So basically how the discussion is going to work, it's going to last about 40 minutes. We have a Q&A set up, and then anyone in the audience, you guys are totally welcome to throw any questions into the comments or the Q&A section.
Very cool.
Awesome. Okay, well, let's go ahead and start. So after watching the film, it's pretty obvious how complex coral is and how complicated the issues surrounding coral today are. I would love if you could just start with like a brief kitchen table explanation, how to explain it to your mom or your dad of what coral is, why it's significant, and how it's being impacted by climate change.
Yeah, sure. So if you just kind of start from the bottom and work your way up, corals are made up of animals. They are an animal, but they're made up of things called polyps. And these little polyps continually basically split off and colonize into kind of a coral colony. Now, just because they're animals, they don't actually get their energy as a normal animal would. They actually have algae in their tissue. I joke that if it were me and you, instead of having our lunch, we would go outside, we would sunbathe, and that would be our meal for the day. And the energy that they're obtaining from that allows them to build their skeletons and essentially create that colony. And that colony is ultimately what creates a reef. So in building this structure, they're creating this massive habitat over, in some cases like the Great Barrier Reef, enormous spaces on the ocean floor. And that in turn makes them really important ecologically because that structure and that habitat that's created by the coral is essentially like a nursery for, millions and millions of creatures in our ocean. In fact, up to 1/3 of all life on the ocean makes its home at one point or another in its life cycle on that coral reef.
Wow.
Now, that's all beautiful and dandy, and it's a really eloquent system that they've designed, but it's reliant on their parameters and their local environment to stay quite stable. And so when you throw climate change into the loop, as soon as your temperature kind of goes a little haywire, this is usually about 2 degrees Celsius, that algae that's producing the energy that kind of makes this entire world go round on a coral reef starts misbehaving. Instead of producing food for the coral, it starts producing really nasty molecules that we don't have to get into. But ultimately, the coral recognizes, hey, this algae is misbehaving. I'm going to get rid of it. So it actively gets rid of its life source, its food source, essentially. And that's an event that we call bleaching. The coral turns white. The funny thing, most people think of the quintessential coral reef with this beautiful array of colors. Well, all of those colors actually have nothing to do with the coral. It's the algae that lives inside of it. And as soon as that algae is gone, the coral essentially is in panic mode, and it will essentially starve to death after about a month if those temperatures don't come back down. So it can be really devastating for coral reefs, and we've continued to see that over the past handful of decades, and particularly in the past 5 years.
Wow. That's fascinating. That is really, really cool. I think someone had a question a while back. So is there any relationship between corals and algae? So to answer that, there is definitely a relationship, right?
Yeah, absolutely.
Mhm.
So, like, symbiosis is one of the fascinating things about nature that exists in many different ways. The most common one that we probably think about is, Nemo or the clownfish that lives within an anemone. The anemone provides Nemo a house and protection, and Nemo will actually feed and even clean off that anemone. And so they're both benefiting. Corals kind of take that a step further with algae where they're actually incorporated into one another. You can't have the coral without the algae. They just can't survive without each other, but it's actually within their cells. So it's an endosymbiotic relationship, which is really cool because it's a more tight-knit relationship than many of the common, comparisons of symbiosis that the average person might think about.
Very, very, very cool. Okay, so before we dive in about the film, I would love to just go over your story on how you became involved with it. I thought it was
Sure.
such an interesting story. Yeah, you started as a camera technician and then was a secret coral nerd, and then they found out, and you really became like one of the like front faces of the documentary, which I thought was so cool.
Yeah, it was certainly never supposed to be that way. I took a job here in Boulder, Colorado, working for a nonprofit that does kind of ocean education outreach, but is paired with a sister company where we build a variety of underwater equipment for marine scientists and for other uses. But our major thing is underwater imagery, so self-cleaning cameras that can go underwater long term. And when Jeff Orlowski, the director, kind of began this project looking into how can we take time lapses underwater, our company just happened to be literally down the street from their office. And we got hooked up and kind of immediately jumped into prototyping these cameras that ultimately you see in the film and what we ultimately wanted to use to capture the first underwater time lapse. So I was just the kind of young kid that was more than willing to be, sent out on a beach to throw these cameras in the water and ensure that they work. And that was kind of my job, hard stop. But the funny thing about making a documentary is, they're constantly filming everything. So at first it's really awkward because it's like, I know I'm not supposed to be in any of this, and I know I'll be cut anyways. But eventually, after a year or two, you get really used to it. Just like the cameras are on, I'm doing my job, and that's that. But I didn't know that my role was going to be, kind of integral to the film, basically until it was finished.
Wow.
So I definitely knew by the end of it that I'd be
Mhm.
in there, but I had no idea that I was going to be, a character by any means.
Wow, very cool. And how many years did it take to film this documentary?
The full film was about 3.5 years,
Wow.
like in the field.
Mhm.
So I only worked on it for like 2.5 of those. I came in about a year in. But yeah, like late 2014, all the way through the Bleaching event in 2016.
Very cool. So it's interesting to see this jump from Colorado, not only you growing
Sure.
up becoming like interested in coral reefs, like that's really interesting. Could you just tell us how that really caught your eye as like a kid?
Yeah, I was quite lucky growing up. I was always interested in nature. Growing up in the Rocky Mountains, I've got pretty brilliant, unadulterated nature in my backyard. But I was really lucky. My father is part of a program that takes a group of about 40 high school students to the Big Island of Hawaii for high school credit every summer. So young Zach was kind of grew up having his summer in Hawaii and shadowing high school kids that were doing marine biology and learning about the culture out there. So I kind of fell in love with it there, free diving and ultimately learning how to scuba. And just kind of committed myself to taking opportunities throughout my life that would allow me to work with not only ocean, but eventually, in a more particular sense, corals. And started working in the aquarium world here in Colorado, actually growing corals here at a local shop to basically provide aquacultured or locally grown coral to local aquarists that just do it as a hobby.
Wow, that is so cool to hear that. I also live in Colorado. I grew up over in California, so the ocean is near and dear to my heart. More kelp forests is what I'm familiar with, but
Sure.
yeah, that's cool to see that there's so much work being done here in Colorado too.
Yeah, totally.
Um,
It's not a bad place to just get involved with really just about anything you'd like to.
yep. Sounds about right. Okay, so for our next question, water covers like 70%, just over 70% of the Earth's surface. But even with that, everything that kind of happens below the surface just seems very removed from our
Sure.
everyday lives as humans, and just like pretty unfamiliar. In the film, you guys talk about how coral reefs and coral bleaching is really like out of sight, out of mind. And I definitely understand where that's coming from. And I'm just interested to see or hear about your guys' approach in making the film, like how to get people to like care about something that's just so removed from them.
Yeah, I think it's pretty complicated. So, like, I've done a great deal of educational work. Like with Chasing Coral, we had an entire impact campaign that I worked on for kind of the first 2 years after the film was made.
Mm-hmm.
And so you're always going to have students or individuals that are really passionate about the ocean, passionate about corals and their well-being. And those people, I don't think you have to do a whole lot of like heavy lifting. You just have
Mm-hmm.
to give them the opportunity and the resources to have an impact. But on the other hand, I also am aware, especially being from somewhere like Colorado, that there might not be everybody that's going to have that type of passion for it. So I think it also comes down to using like the film or the story of coral reefs as inspiration for somebody to do something in their own neck of the woods for what's actually relevant. So, for instance, here in Colorado, I'm going to get a lot more people's ears to perk up and get their attention if we talk about the demise of ski season potentially than if I just keep pushing the coral reef aspect to them. So part of it is to provide resources and provide actionable items to the people that are really stoked about coral reefs, and then secondarily to implore people to use it as inspiration and really dive into their own local communities and find ways to make it happen on a smaller scale, because we're all attached to the ocean. And Colorado is another great example because we're the headwaters state. The actions that we have here, whether you're on the
Mm-hmm.
western slope or the Front Range, that water is going to the ocean, whether it's the Atlantic or the Pacific. So what we do in terms of pollution or plastics or fertilizer or just sustainability in general does have an impact down the road.
Yeah.
Sylvia Earle always says the ocean starts at your front door, no matter where you live.
Mm-hmm.
And I think that's really important to kind of dig into people's heads.
Yeah, totally. Just making it relatable. Um, okay, so how is it going down there for the corals today? Like what is their current state? Have things changed since the film came out in
Um,
2017?
yeah, bleaching hasn't necessarily been the greatest. So our film covers bleaching through kind of this massive El Nino event that went
Mm-hmm.
from 2014 really through 2016. Unfortunately, on the Great Barrier Reef, 2017 was another mass bleaching event, mostly focused on the central region. So they got hit with back-to-back mass bleachings, in 2 consecutive years, which is pretty devastating. So I believe in the film we used the number 29% of corals died in 2016. Well, after 2017, that number is more likely 51%.
Wow.
And then unfortunately, while all of this COVID-19 stuff's been going on, Australia just had its third mass bleaching event in the last 5 years. This spring, or
Mm-hmm.
our winter. And that one was actually the most widespread. The severity right now, it's looking like it wasn't, as much mortality, but
Mm-hmm.
it was certainly much more widespread throughout the entire park. And unfortunately, it was very focused on the southern portion. So in the film, we do a huge amount of work in the Keppel Islands where it didn't
Mm-hmm.
bleach. And that was actually one of the hardest hit locations this year, unfortunately.
Wow.
Um,
Oh,
but on the positive side, these ecological disasters or tragedies, kind of kick the door wide open for really cool and novel research also. And there's more people and more eyes on the topic because we've been talking about it more.
mm-hmm.
So that's kind of a bonus, is we do have, I think, a little bit more resources going towards let's figure out what we can do, whether it's from the pure scientific side of things or just understanding, the best methodologies for conservation moving
Yeah,
forward.
totally. So once these corals start bleaching, is there any way that it can be reversed, or is it kind of just irreversible at that point?
No, it all comes down to how long the temperature lasts, right? So the
Mm-hmm.
funny thing with bleaching is it definitely comes off or has this connotation of being just this 100% disastrous event. And while it is disastrous, if it gives enough time, that corals are actively making this choice.
Mm-hmm.
It's a survivalship mechanism. If they didn't bleach, they would be dead, in a matter of days rather than a month.
Mm-hmm.
So if the temperature does come down, then they can actually, reinvest themselves with that algae. In fact, most corals aren't fully getting rid of it. They're keeping a
Mm-hmm.
handful in their tissue, and then they can use those to replicate after the fact. Some corals do it a little bit differently with sediments, but yeah, timing is everything. We use something called degree heating weeks, which
Mm-hmm.
essentially is just the buildup of heat. How long can the corals last during this stressful period before they don't necessarily have the energy reserves to continue living?
Yeah, that is very, very cool. Um, okay, so in the film, you got to speak to your hero, Dr. Charlie Varone. He's the godfather of coral, kind of from what you were talking about, and it was cool as a viewer to be able to like watch that relationship develop. What
Sure.
did you take away from his perspective?
I mean, Charlie is a fantastic dude. He's,
Mm-hmm.
really the godfather of coral reef science. He's certainly seen, a lot. So he has some level of cynicism to him, just because he's, watched this ecosystem from its full glory and kind of the advent of scuba in Australia, all the way till today, where things have been better.
Mm-hmm.
But at the same time, I think that I've seen a change in him over the past few years, also to where, he's continuing to work with people and continuing to spread that word and try and get more and more involved in being, somebody that can be a big promoter for organizations that are doing really fascinating work. So, I've been able to dive with him a handful of times even after the film. The fantastic organization called Great Barrier Reef Legacy in Australia, where both him and I were part of that, and we actually, I was able to be there and photograph the first newly discovered coral species in like over a couple of decades that he had found. And
Very
I've had some really great experiences with him, and he
cool.
really is a fantastic man, and a joy to be around. Hilarious. But yeah, just overall cool to have like built that friendship over the years with him.
Yeah, that's really cool to be able to connect with a hero to yourself and then kind of him become a mentor to you.
For
That's
sure.
awesome to hear that. Um, so what initiatives are you working on at the moment to like continue this education? At the end of the film, it talks about how you started you kind of weeded out a school bus and turned it into like a mobile education mobile. Is that still going on? What else is going on?
Yeah, there is still a school bus. Right at the moment, it's not doing a whole lot. And I worked on the impact campaign for about 2 years and was able to reach kids from all over the world and traveled the country and different places, throughout really the globe and work with kids and be able to do things like that. I've actually moved on from that position. I'm starting my PhD this fall at the University of Hawaii. So I'm no longer really running those things,
Mhm.
but obviously Chasing Coral is still alive and well. Really, with the advent of this whole quarantine situation, it's kind of been given new light, which is pretty cool to see. So I've been doing a lot of these things while I'm stuck at home. But unfortunately, I'm not really boots on the ground as much as I used to be. But kind of moving on to the next thing and hoping to put my science hat back on a little bit and work on that.
Nice. That's awesome. Congrats. Um, all right. So I'm sure all of us are kind of sitting here and like wondering like what can we do as an individual to help out?
Sure. Yeah, it's a really complex question. If you have access to coral reefs or have the ability to, experience the ocean, then the answer is a little bit different. I think the number one thing is, that experience in itself goes a long way. Taking family and friends out onto the ocean, cultivating a relationship with that ecosystem really ultimately builds like our care and our ability to love and protect something.
Mhm.
But most everybody's not in that position. Less than 1% of people have an opportunity to spend time underwater. So it really comes down to your local communities. And we kind of touched on this previously. Like, there is no silver bullet to climate change or to these issues, But if we look into our own community, whether that's our city or our neighborhood, our home, our school, we can kind of identify where our strengths are, where our weaknesses are, and attempt to, battle those weaknesses a little bit more. Because the answer is going to be different in a place like Boulder, Colorado, which is historically incredibly green place, compared to somewhere like LA or New York City. So the answers are always different, but I think it's about getting involved with local organizations that are doing good work, and sharing these stories and building, experience and relationships with your local ecosystems.
Totally. Yeah. So I think we have one question from the audience. They're saying in the documentary, it details a certain photography technology that was used. I'm not sure if they're talking about the mapping or if you want to just kind of talk about what was.
There's a few different things that we did. The first and foremost, ultimately this documentary started with Richard Beaver's program with the Ocean Agency and then XL Catlin Sea View Survey. And they developed a camera technology that was essentially a giant 360 camera. You can liken it to the cameras they use for Google Street View. And it's basically put onto a propeller underwater. And they can drive that and essentially do coral transects and create 3D maps of coral reefs, which ultimately ended up being Ocean Street View or Ocean View on Google Maps. And then that's also what we use for our virtual reality technologies, on things like Google Education, Google Cardboard, things like that, Google Expeditions. So that's kind of the 3D technology that was developed, kind of pre and during the film. And then the technology that I've worked on with Trevor Mendelo and View Into the Blue is essentially just your average security camera, but it goes inside of a glass dome, and basically we created a system of magnetic rings that pulls a windshield wiper around that glass dome. The issues with underwater long-term imagery is the name of the game on any marine ecosystem is a competition for space. You put something brand new and clean underwater, it takes 11 hours for calcification of organisms to start building on that. And so if you just leave a camera underwater for a time lapse, the next day your footage is essentially bunk right off the bat because it's covered in slime and algae and little calcifying critters. So we designed a technology to basically mitigate that biofouling problem and get you a clean image over long periods of time.
Yeah, seems like a very complicated process, but yeah, it's so cool. I was able to check out the Ocean Street View, and that is just such an awesome feature.
Yeah, cool stuff in there for sure.
Yeah, so cool. And even I think today, there you can just kind of see an increase in underwater mapping. I know like even some national parks are starting to do benthic mapping of their underwater surfaces too, which is just really cool to see that come in.
Yeah, technology is definitely making things easier in the underwater world.
Yeah. Okay, so we have another question from Kelly. She says, good luck on your PhD. Do you know what you're going to be focusing on?
So I don't have like everything fully intact yet, or an understanding of what I'll ultimately be doing. But right off the bat, I'll be advised by somebody named Dr. Elizabeth Madden out there. And one of the things that she's been looking at is essentially what we've been talking about, using innovative technologies as conservation tools, which is really exciting. And she's also looked at something called reef halos, which are essentially like a patch of kind of clear sand in between a reef and then maybe like an algal bed or a seagrass bed. And those are kind of indicative of reef health also. It has some predator-prey interactions involved there. The fish that live on the reef don't necessarily venture super far off of the reef, and they create these kind of grazed halos. And one of the ideas is that potentially those could be used either by satellites or by trap cameras to actually be indicative of reef health, and that we could use them in that fashion, sort of. But yeah, still going to figure it out. I only get out there in a couple months, and then I'll be able to, give you better information.
Cool. That's really, really exciting. I'm excited to see how that goes. So before we close out, is there anything that I haven't asked you about or haven't brought up that you would like to share before we close?
Not necessarily. I think one of the common questions that we do get is, about the realistic ability of corals to actually be able to make it into the future. And it certainly does kind of come down to us. We have to kind of hold our end of the bargain for corals to be able to do it, but they are set up for success just simply by their physiology. And what I mean by that is really their reproductive strategies. So corals don't, make babies like the vast majority of other organisms. They spawn. So on a single night in Australia, this happens in November. On a full moon, every single coral on a coral reef, or at least the vast majority of them, will actually release their gametes, their eggs, and their sperm into the water column. And we're talking about trillions and trillions of potential coral babies now just free floating in the ocean. And these can be taken, theoretically anywhere via ocean current. So even if we were to lose, say, 80, 90% of coral reefs, the reefs that we do leave intact, if we can get our act together, they actually do have the capacity to kind of reseed areas around them, given the opportunity that we're not hitting them with back-to-back bleaching events, and we have some stability that's not going to impact them or the baby. So that's always really fascinating, and I think the science there that's kind of going on, whether it's on the genetics as well with these corals, is really promising, and I think it's really exciting as long as we can kind of figure out our own deal.
Okay, so we have two more questions from the audience. One person is asking, aside from bleaching, have you seen a large increase in coral diseases while diving?
Coral diseases are certainly always an issue. Right now, it's actually probably a bigger issue in places like the Caribbean. So we do have like a necrotic tissue disease that's been ongoing in the Caribbean for the past handful of years. And it's certainly spread, pretty quick over the past 12 months or so. I know I've got some friends out in the Bahamas. They've run a company called Coral Vita that does some amazing work. And they've been working on some, methodologies for trying to save some of these corals that are impacted by this disease. I know it's in the British Virgin Islands now, and it's obviously been in the Florida Keys for quite some time. So that's the big one right now. And the second one that we see that's almost kind of affiliated with bleaching isn't necessarily a disease as it is a parasite, and that's crown of thorns starfish. So after bleaching events, it does seem that crown of thorns starfish actually become more prevalent or have the capacity to have outbreaks at kind of bigger levels than they would just in a normal year. So you do see reefs get wiped out, quite quickly in a matter of weeks when you have huge outbreaks of these starfish that eat the coral. Those are probably the two biggest ones. There are a handful of other diseases that have been around for a while, but none that are wiping things out, as rapidly as what's going on in the Caribbean right now or in the Northern Caribbean.
Yeah. Wow. So a few more that are emerging. I think this one from Roxanne, you kind of addressed two questions ago. Do you think that we'll be able to make changes before we lose these ecosystems?
Yeah, I mean, that's a hard one. I think the corals are backed up in a corner, and I think their outlook's pretty grim no matter how you cut it, unfortunately. The odds of us as people doing it is definitely less than, the odds of us in the scientific community being able to, come up with ideas and novel methods for trying to protect what we can while we can. So it's definitely a tough question. I think that we're going to lose the majority of coral reefs. I don't think there's a real big doubt about that. But I think there is hope in the fact, like I said, that both physiologically for the corals and both with the human condition, that we can at least protect a handful or the batch that we think has the best opportunity for survival and hopefully ensure that for the future. And I guess that's really where the optimism lies. And secondarily, it's in kids, right? Like kids get it, and I think the younger generations are certainly understanding of the world that they're being handed. And so I think that in itself gives me hope, because they're the ones that ultimately are going to have to fix this. We certainly have to do our part, but as things progress the way that they're progressing, I think that's where the real optimism should be, is in educating the future generation, and not only educating and imploring them to use their voices, but providing them the skill sets, more importantly, to actually go out and be involved in their world when they come into adulthood.
Yeah. So it sounds like education is just like really going to be key moving forward if we really
experiential education.
Yeah. Yeah. Okay, so let's do this one as the last question. It's from Allie. She says, if we turned 30% of the reefs into protected sanctuaries, would that be enough?
Yeah, so protected areas are always fantastic, right? Whether they're no-take zones or simply like the Great Barrier Reef. The entire thing is protected. You can fish in certain areas, but the entire thing is essentially a national park. The difference here is that the ocean is a little bit different. Like we can protect them all that we want, but just by labeling somewhere a marine protected area doesn't make it less susceptible to random heat. So yes, they're great in terms of the other factors that are impacting coral reefs, such as nutrient runoffs or overfishing. A lot of these variables that are localized that are directly anthropogenic. Somebody's doing something wrong on the reef. It doesn't necessarily protect them from the impacts of climate change. The water's going to be warm. It's going to be warm, and whether or not we put a label on it, it's irrelevant ultimately. So would it be great to have 30%? Absolutely. It's going to be, hugely helpful in terms of the longevity of coral reefs and mitigating some of these factors. But we also have to hold our end of the bargain because the hot water isn't going to stop around imaginary boundaries.
Yeah. And yeah, I think that just ending on that just really highlights how complex and complicated these issues and any answers to the coral is really. So thank you so much for making something so complicated, like Ali saying, so accessible. And I think, science communication can be tough because these are such tough issues, but just being able to explain it and understand it like this has been so helpful for me, and I'm sure many of our viewers too. So thank you so much for coming out here and talking to us today.
Thank you guys for putting it on and keeping the longevity of the film alive. It's been really cool to see an uptick in people talking about it while we're kind of all stuck at home and learning new things and watching cool films.
Yeah, cool. Okay, well, if you guys enjoyed this conversation with Zach today, definitely go watch the film if you haven't seen it already. It's on Netflix. It's really great. And if you want to stay connected with Movie Club, follow Global Inheritance on Instagram, or you can go to our website and sign up for Movie Club. Each week we're sharing recommendations for our favorite cause-based films, from social to environmental issues, and we're hosting weekly discussions like this. So thank you all for joining. Thank you again so much, Zach, for coming and talking with us. This is a really great conversation and leaving me hopeful for making a change and a positive impact for coral in the future.
Yeah, absolutely. Well, thanks. You guys were awesome. Great questions too. Gotta love it.
Thanks. All right. You have a good one. Stay healthy. Bye.